Welcome again to another edition of the Southwest Climate Podcast. I'm here with Mike Crimmins, who is officially back off his 6-month sabbatical and well-groomed, I might add.
Oh, I did actually finally take that sabbatical shower, post-sabbatical shower.
Yeah, I figured you spent the last 6 months sort of watching TV and getting boned up on all of the new climate journals and
exactly binge watched all of those Netflix shows on climate.
Well, it's good to have you back in the office, Mike.
Yeah, it's good. And you were kind of gallivanting across the world.
Yeah, we both spent a good part of June outside of Tucson, outside of the Southwest, which
smartly.
was I think we've wised up over the years to sort of escape the doom season. But we have a lot to talk about because it's been a little bit over a month. This is again our first episode of the 2017 Monsoon edition.
Most wonderful time of the year.
Best time to talk about weather and climate. More weather than climate, but climate obviously plays an important role. So in this edition, we're going to try to hit on three major topics. Obviously, we want to recap June, which was dry and hot.
It's kind of as we expected. I think we may have even have been prescient in the our last podcast by suggesting that June was going to be hot and dry.
Yeah, we went out on a limb on that one.
We did.
So we'll talk about the June temperature and June climate, and that, of course, we can't have that conversation without talking about wildfire activity, which has been pretty widespread, and talk about the fire activity around the Southwest, and then that will take us up to the first part of what's turned out to be a pretty quiet monsoon, but we'll get into that.
Right.
So June, Mike, you disappeared the latter half of June. I was gone for pretty much the full month, but
I want to point out that I was here a lot more June than you were.
You were, which is why we're going to lean on you on this. What I did realize is that I missed the 122nd coolest June on record.
Don't play with my mind like that.
It was the 122nd coolest out of 123.
123 years. Yeah. Okay.
Well, I'll flip that around.
Okay.
So June for the statewide average turned out to be the second warmest on record.
For the statewide
average. And if you break that down and look at the climate division ranks, particularly if you focus in on the maximum temperature, all but one of Arizona's 7 climate divisions saw their warmest average maximum temperature on record. So it was indeed a very warm time in Arizona. For Tucson, Mike, we set a number of actual daily records.
It was the hottest June on record for Tucson. So I'm looking at the local Tucson Weather Service June 2017 climate report. It was the second hottest all-time high temperature on record for Tucson, and the 7th hottest of any month on record for Tucson as well.
People may remember last June was also epically warm, but this was warmer.
This one was epically warmer. Absolutely.
Epically warmer.
Can you say that? Epically warmer?
It's not exactly the most eloquent way to describe it.
Well, that's what for 6 months in sabbatical, I did a lot of sort of training, public speaking, that kind of stuff.
So we had four records in Tucson, 4 maximum temperature records. From the 19th to the 25th, the temperatures were either close to 110 or above.
Right.
A very warm heat wave. Were you here for that?
I was here for that. And yeah, so if you look at the extent of the record temperatures across the Southwest, the whole western U.S. for the month of June was actually above average, but the epicenter for the heat wave was really on Arizona and a bit of western New Mexico. But as far as places experiencing some of their record warmest for the over 100-year record was parts of, well, as you just pointed out, much of Arizona. Yeah, it was really Arizona kind of undergone for that. It was miserable. How do you know it was miserable?
I'm imagining. I've been here for those. I was here last year during that time.
I think in our podcast in the end of May, we were talking about how we can quickly transition into some of these heat waves, and that was really what happened. And it was almost to the day. It was to the day, actually, last year, the heat wave that was over kind of around Father's Day. With June 19th of the peak of the heat wave last year, it was right around those same calendar dates, but we ended up having higher temperatures and for multiple days across much of Arizona.
Yeah, so on the 19th, 20th, and 21st, the temperatures here in Tucson were 115, 116, and 115, and those were all records.
Yeah.
In Phoenix, for those who are tuning in from Phoenix, for those same days, it was slightly warmer, 118, 119, and 117. Those are high temperatures. It's also worth pointing out that in the month of June for Tucson, 25 of the 30 days were above 100 degrees. So that wears on people.
It does.
I mean, from afar, it was wearing on me.
It just thinking about what temperature was like. I'm gloating because you are gloating.
This is the first summer that I've wised up and decided, and it wasn't actually by intention. It was just more of a work trip, but I decided to escape for June.
It was a surreal heat wave, and I think that what stood out for me was typically these things they culminate with a day and then they sort of retreat, but this really went on for days, with a brief retreat and then another pulse later in the month where we were back up to near record temperatures. It was a remarkable heat wave.
So what was the synoptic pattern that was producing that? I mean, again, we expect dry and hot weather, at least through the end of June, and the monsoon sometimes can creep in a little bit before June. But up until that period, this is the expectation. But was there anything, maybe you can take us through the sort of the atmospheric pattern that helped lead to the heat wave?
What we've seen is a fairly typical busy mid-latitude jet stream pattern, which you should start to see is starting to retreat towards the north. As the days get longer and we're peaking with the day length on June 21st, is that we're starting to heat up in the northern hemisphere, and we expect to see the storm tracks sort of retreat north towards the poles as that temperature gradient.
So less intrusions of sort of colder air from the north.
Yeah, so that jet stream is going to be at the gradient between the cold air to the north and the warm air to the south, and as the warm air, the whole northern hemisphere warms up, that colder air is really sort of shunted up to the far northern reaches where they have less sort of solar radiation, and we have more direct heating down here at the lower latitudes, so we expect to see that go. But there's these waves that are propagating around in the jet stream, and those wiggles will shove highs and low pressure systems sort of in and out of position. And so what we saw sort of early on in the month was still a fairly active jet stream, some troughs sort of progressing through the Pacific Northwest, and our monsoon ridge, subtropical ridge, is now starting to try to build north. And it's doing that sort of in concert with the heating of the land surface across the western U.S. There's an interplay both between the sort of jet stream pattern and then the land surface contrast between the ocean and the warming land surface. And so we had, in the middle part of the month, a pretty pronounced what we call meridional flow, where you've got pretty strong sort of shifts in the jet stream. And we had a ridge of high pressure build fairly sharply north across the western U.S. And as you do that, you can have some, reasonably strong dynamics that will cause sinking air in concert with all of that surface warming from all those long days and direct solar radiation that's starting to get pumped in at these higher latitudes. And that in concert together will work together to really reinforce the heating at the surface. And then you don't have the clouds. You're going to get these heat waves that kind of emerge. So it's kind of a perfect time of year for down here. What ends up cutting these is when the monsoon moisture starts to come in, you start to produce convection, you start to produce clouds, and then you just can't get as much of those heat waves persisting like we did in June.
Yeah, and we had real low precipitable water basically until July 4th.
Yeah.
And so there was not much moisture around.
Very typical, very typical. You don't have, you're on sort of the ridge is building in, the north side of the ridge. You've got subsidence, you've got wind out of directions that's not favorable for transport of that subtropical moisture yet. And it's going to lead to very dry, hot conditions, which is climatologically what you'd expect.
The monsoon has started a little bit later than its historical average, and certainly a couple weeks actually later than last year. And some questions that might arise is, well, did this heat wave, did the heating actually delay the incursion of the moisture? Is there any relation between, that intense heat and those conditions and the fact that the moisture didn't come in until a little bit later this year?
No, I think really the delay has been a noisy jet stream pattern. And what ended up happening was that we had that, if you look back to the sort of synoptic, or so that broad scale circulation pattern, there was at the upper levels, there was a a cutoff low at upper levels. There was the sharp ridge that was leading to our heating and intense sort of heat wave. And to the north of that, we still had some good wiggles in the jet stream. And then by the later part of the month, we had a pretty good trough set in across the western U.S. and into the central U.S. that shoved the subtropical ridge back to the south. And once you have that, you're back in the westerlies. You're back in the sort of late spring pattern then. The heat can still be there, but the moisture is going to be shunted to the south. So you got to wait for that ridge to rebuild in across the region. And so it was pretty noisy through late June and even early parts of July. We still had pretty weak troughs sort of traipsing across the western U.S. And it wasn't until July 9th you start to see the ridge build back in. And you're really starting to see the jet stream to the north sort of weaken and us get into this much more typical summertime subtropical ridge sort of setting up across the western U.S. And so I think now what we've settled into it, we're probably now more in that consistent summertime pattern we'd expect to see. It seemed to me anyways is fairly typical in the noise around that sort of July 4th in the southern Arizona start date. But, you can look in New Mexico. New Mexico had a pretty wet June with all sorts of different sort of mechanisms sort of bringing in the moisture there. And we were a little bit later, but I do think we're now into the monsoon pattern, and we should be consistently with all of the caveats that go along with that.
Woohoo! It's worth saying, though, just to point of emphasis or an exclamation point on this heat talk, put this in maybe sort of a broader context. The first 6 months of average temperature for Arizona for 2017 is so far the second warmest. So the year since January through June, it's been the second warmest. That is also the case for New Mexico. Utah is coming in at, I believe, the fifth warmest on record. Colorado, the third warmest on record. So this is the start of this year. And in fact, if you look at the U.S. as in its entirety, it's trending right now at the second warmest on record in 123 years. So we're in, I guess, in play for the warmest year on record. We'll have to see how that plays out with we're only halfway there.
In looking at the daily temperature plots for a couple of places across the Southwest, just sort of thinking back from January 1st, as you were sort of pointing out that we're on this track to be maybe the warmest year on record, is that just thinking through the heat waves that we've seen in the Southwest since January 1st, we've had multiple of them. And if you think back to we had a March heat wave for the second year in a row. We ended up having this kind of miserable June that even trumped last year, which we thought was an epic heat wave. Tucson has seen, out of the last 192 days, has seen 142 days with above average temps, 50 with below average temps. Phoenix has seen 131 days with above average, Phoenix seeing 62 below average. In Albuquerque, it was 140 days above average, 52 of those were below average. So that's how you get to, on a daily weather basis, getting an annual average temperature that sets the record. It's sort of that weather versus climate mix.
It's often the really anomalous, the heat waves that happen outside of the months that you expect it, that do more damage than, like, everybody expects there to be very hot and to be careful during June. But in March, even if the absolute temperatures aren't as high, they can actually catch people off guard and cause more issues than the ones in June. So when the heat waves happen, even if the absolute temperatures aren't as high, really does matter.
And sort of looking at these plots, thinking back to how this year has evolved so far, and then having this, culmination of another it was a pretty epic heat wave. So we have to give credit where credit's due as far as this June with just the run of the temperatures. And I think the thing that, and just trying to do a little bit of a postmortem on it and looking at some of the charts, really trying to understand what were the sort of mechanisms at play. You have the climate change aspect of this is absolutely part of the equation. Is not 100% attribution saying that this wouldn't happen, but it's certainly the background condition that makes it a bit easier for these types of events, because the dynamics didn't look all that particularly impressive as far as the strength of the ridge, the position of it.
Well, if your baseline temperatures have shifted a couple degrees,
it gives you a little bit added boost when you get a dynamic situation with the synoptics here, that it allows you to sort of reach some new temperatures for some length of period there. So it'll be interesting. It'll be interesting to see attribution studies that are going to be done on this to really try to pick that apart.
Yeah, and it's worth also pointing out, and particularly because this is different than last year, is that June did not receive any precipitation.
Yeah, that's right. Right.
And that actually reinforces the temperatures. So when you do have rain events, you tend to have cooler conditions, just not only from the evaporative cooling that happens after, but the cloudiness. And
yeah, I mean, you could have envisioned that with this particular ridge position and sort of building north, that we could have had some subtropical moisture starting to seep in as sort of the early monsoon signal. We didn't see that. And even just having a little bit of that moisture seep in, giving you some cloud cover would have taken the edge off the high temperatures. We wouldn't have reached those high temps. Would have seen the overnight temps still be higher. So we would have maybe have seen just the same with the average daily temperatures with that particular heat wave.
That, of course, has an influence on fire, which is the other big thing that we pay attention to during this part of the year up until the monsoon season, because June and even July is, for the Southwest, it's their peak fire seasons.
Right.
That activity has ramped up in June and actually continued quite vigorously in July as the monsoon came in a little bit later. And so right now, the total acres that have burned in Arizona is close to 300,000. And this is slightly less than what was burned in all of last year, but we're going to pass last year's mark. And currently, there's a number of fires that are ongoing in the Southwest. More than half of the acres that have burned thus far have been part of fires that are ongoing. 5 fires that are currently in Arizona are receiving the Type 1 incident management teams from the firefighting agencies. The point that I want to make there is, had the monsoon come in a little bit earlier, had it come in when it did last year, that's probably something that a fire that would not have started.
Yeah, and I think you can look across the Southwest here too and look at the fire activity that's sort of progressed across Arizona and New Mexico through the spring and into the summer here too, is that there's been less activity in New Mexico, and I think that's largely due to them having much better precipitation sort of in the spring and then into this sort of early summer period. Arizona's kind of left out of that. We did end up, so Tucson proper did not have any precipitation in June, but other parts of the state did have some storm activity at higher elevations, which did lead to some fire starts from lightning. Mm-hmm. And then we've also had quite a few human starts with the fires across the Southwest. So it's kind of a mix of what's burning where and what caused it. But absolutely the fact that we haven't had a real good, strong influx of moisture and then precipitation across the state is why we're still dealing with some of these fires.
Well, I've noted that there's 5 fires that are currently burning that started June 30th or later.
Okay. Yeah.
There's the Burro Fire here, which we mentioned. That's as of a couple days ago, consumed about 27,000 acres. There's the Sheet Fire, which actually has only consumed about 4,000 acres, and that's in the Dos Cabeza Mountains in southeast Arizona. And then there's 3 around Flagstaff: the Bull, the Cedar, and the Brooklyn. Mm-hmm. Brooklyn Fire is the largest, 33,000 acres. Each one of those is what the fire agencies consider their Type 1 response. So again, this is where they apply the most resources, right, and where they're
highest level
working,
of,
highest
hierarchy
level
and management with it, right?
The Bull, the Cedar, and the Brooklyn near Flagstaff started on July 7th and 8th.
They largely have been lower elevation fires, so probably feeding off of some of the fine fuels that have accumulated over the last couple of years with monsoon activity, and then being able to take advantage of the dry conditions of the spring. Haven't seen a ton of real strong activity in the upper elevations because there was a lot of discussion sort of earlier in the spring that there was going to be more of a worry with lower elevation fires and higher elevation fires. And I think that's largely played out. But as you get later and later into the spring, you get a June heat wave like we've seen, you can start to see those heavier fuels at the upper elevations they can come into play too. And we've seen some pretty active higher elevation activity with the fires, burning through forest areas now, because I think they've had plenty of time to dry out. And to your point, the monsoon can be really shut the door on that spring activity. And we're kind of on the edge of that with the humidity in, and we need a couple good more dousings of sort of widespread precipitation at higher elevations to really put an end to this fire season.
Finally, at least for Tucson, and again, the monsoon is very much an individual experience because it is different depending on what house you're sitting in for the most part and where you're living. But for Tucson, our first rains didn't start until not June. We don't want to go back to June. July 10th.
Right.
And juxtapose that again with last year, Mike, where our monsoon came in 2016 for Tucson. I think the 27th of June actually was.
Yeah, right.
Was the 28th of June, and we actually had quite a bit of early precipitation, 2.5 inches by July 2nd for Tucson. Fast forward a year, I mean, it's a different picture.
This is always the interesting thing about the monsoon season is where in a period of 2 weeks, we can call something early and something late. And as far as a climate phenomena, that's saying a lot, isn't it?
I guess it's saying there isn't a lot of variability around when the monsoon starts, right?
Yeah, and we had a lot of deep existential discussions around here with Ben and you, and Dan was even in here talking about when did this thing start? Does it matter? How do we best measure it? We've got the old dew point definition, which I think we would have met on July 10th, based on 3 consecutive days of 54-degree dew points or greater.
Let's say we use that definition because this has been a historically used way. If we use July 10th as the onset of the monsoon, but July 10th, then there was only 9 years that started after that, since 1949. By that definition, it would be a pretty late start.
Right.
Interestingly, could have been worse. In 1987, that dew point threshold wasn't crossed until July 25th.
That sounds terrible.
Yeah.
I don't even know what to say about that. So I guess it was the late June activity monsoonal last year. I guess it doesn't really matter. I think it probably was monsoonal because it did end up having the dew point definition and consistent rainfall for there. Turned out that it slowed down quite a bit for the next subsequent 2 weeks of July, and then we didn't have a pickup in activity till later on. So I think we're trying to use last year as a comparison to what we might expect this year. We didn't have that same activity, so now we're here in July 10th. This is absolutely a bit later. It's not the latest. It's kind of in that, what would you call it? We're off the mean of July 4th, so we're kind of in that sort of later tier of activity. Does it give us any indication of what the rest of the monsoon might be like? No.
Well, and that,
I don't think so.
Yeah, no. Anecdotally, we can use last year as. In fact, I remember last year on this podcast, I was saying we're playing with house money after the first 2.5 inches fell by like July 4th. That's right. And it turned out that
you spent a lot of house money after that for the next 2 weeks is what you ended up doing.
Yeah, I guess I have to think more about how to. There's so much anticipation. I think this is what you're saying around when the monsoon starts that. And we want to experience a longer monsoon than a shorter monsoon.
And I think it's that. I think that there's all this sort of emotional buildup and expectation for something right on July 4th. There is tons of sort of conventional wisdom around that it always rains on July 3rd or July 4th in the afternoon of wherever you are standing in the Southwest. I've heard that pretty consistently. And now that people aren't experiencing it, they sort of think that there's sort of a trend. We don't really see that in the data, and the fact that the monsoon season really isn't very long. If you get 2 weeks into it and you really only get a good 8 weeks of activity out of it, you start to feel cheated. And I feel that too as days slip away, like we're missing a chance here, right? And so, but it's not, July 10th is not outside of historical variability. It's a little bit of a bummer since we had all of that heat to contend with, but now that we're in it, I think now we should look forward. Let's stop talking about the past now, Zach.
Yeah, I want to talk about last year.
Okay. Then what do you do?
One more point though, because I want to emphasize what you're saying.
I guess I'm a climatologist. As you talk about the past.
We have to put this in the historical record. That's our job.
Oh, that's right. Forgot about that. Okay.
The monsoon started, let's say, even a week later, which is a substantial amount of our short monsoon season, that it's not a predictor of what is going to come. And last year, by July 2nd, we had close to 2 1/3. So we were a third of the way there. And yet, we finished above average. But if you look at the second half, it didn't hold up to what the first half showed us. So from August 10th onward, or August 11th onward, there was really one substantial rain event at the airport.
Yeah.
And again, that's not indicative of what else is going on, particularly at higher elevations and other areas. But the point here is, we started a little bit slower this year, but we don't have house money, but I'm not even sure that analogy actually is appropriate
It's your analogy.
Well, I don't think it's appropriate.
Okay, so, and this is the tough thing that we have about the monsoon every year is that you and I experience different monsoons because you live on the west side of Tucson and I live on the east side of Tucson.
I live close to the airport.
You live close to the airport. Okay, so you exist in the real monsoon, right? Because we only do the data analysis.
It's all about the international.
I live on the
airport.
east side, which is we're out in
data hole.
It's wilderness. It's the climate wilderness on the east side. We
have to use remotely sensed images to figure out if it rained over there.
That's basically it. Yes.
i.e. rain log.
Rain log. No, actually, that's thank you, rain loggers out there, for doing what you do. The interesting thing about last year was that we had this discussion in Tucson about our June event. Well, that June event didn't happen everywhere in the Southwest. It was a very localized event, and it was a very showy event because it flooded out parts of Tucson. It was a couple of really good rainy days. It was really quite impressive, but you didn't have to go far to see that event was fairly localized. So you got a bunch of house money in Tucson, and parts of Tucson got way more house money. But the rest of the monsoon season, if you go to Phoenix didn't see its first substantial monsoon rainfall to well after July 15th, which is when we picked back up on the monsoon activity. So, last year looks a whole lot more like this year as far as that break, just in thinking about the timing of the precipitation and even some of the temperature patterns that we've seen here for other parts of the state.
If you go back through the record, historical record, you can find every different flavor of the monsoon. Monsoons that started early, monsoons that started late, monsoons that were characterized by basically two events or one event, monsoons that were characterized by a whole bunch of small events.
Yep.
There aren't any actual coherent patterns that you can...
Not really. I mean, and there's good research around this too, of people trying to do studies of time series analysis, of looking at cyclical nature of rainfall events, or is there any predictability if you have a late onset at a location of overall seasonal totals, and there's just not a lot of good relationships that emerge from that because it becomes very sort of day-to-day weather driven at the location within the monsoon season. So we do end up taking it back day by day. And then looking back to the historical records, like you said, we see just all sorts of different flavors that become kind of incoherent when you sort of scale them up and look at multiple stations all at once.
Let's deconstruct a little bit of what happened up until a couple days ago. We've talked about this before. Last year, we sort of reviewed the ingredients that are important for, widespread precipitation. Those being, you have to have moisture present. Mm-hmm. And those can come from a couple different sources. They come from the east, and they also come from the Gulf of California, Baja California area. So you have to have a moisture supply. You have to have dynamic instability as well. You have to have the ability for that moisture that's near the surface to rise up, to condense, and to rain out. And so temperature profile in the atmosphere is important, along with the moisture. And if you have those two, you also need some steering winds, and winds aloft. And if you have winds aloft, you can blow the precipitation that oftentimes starts to form around the mountains first. You can blow those off the mountains into the valleys. And if you don't have those, but you do have moisture and you do have some instability, then you can get precipitation that is more centered on the higher elevations. And so what I was looking at, the first 10 days or so of July, the moisture wasn't really there.
Thinking about the evolution of that, synoptic pattern, when we're talking about sort of the weather circulation pattern, is that we had right at the later part of June and into the early part of July is we ended up having a couple of jet stream disturbances come across and really knock the subtropical ridge out of position, sort of shunted it back to the south. And as soon as you're doing that, you're back into sort of the dry fetch of the westerlies. You're more spring-like than you are summer. And it's only been until very recently we start to see that subtropical ridge build far enough north that we're not on the north side of it, which is in the westerlies, but we now start to get that ridge to the Four Corners, which is why we call it the Four Corners High in the upper levels, to start to now see more of an easterly flow, a southerly, southeasterly, and easterly flow at different levels of the atmosphere. And then you have to have that subtropical convection occurring to the south and to the east, and then the ability to actually have these Gulf surge events come up the Gulf of California to start to put together the amounts of moisture that you need at different levels of the atmosphere to take advantage of the thermodynamics of just having all this heat here.
So how do you get those surges?
you've got to have the right sea surface temperatures in the Gulf of California, which actually progress up through the Gulf of California and warm up to get to a point where they become unstable enough to start to break through. They actually have a marine layer inversion on the Gulf of California. And then once it warms up, that Gulf of California water gets anywhere from the upper 80s to almost 90 degrees. And then it's super juicy, giving off a lot of moisture to the atmosphere and creating a real soupy low-level air mass. But what you'll end up having is thunderstorm complexes down in Mexico traversing across the opening of the Gulf of California, or a hurricane that will come up there. And once it does that, the cool air mass, high pressure at the bottom of the Gulf of California interacts with the really hot surface thermal low in Yuma and sets up a pressure differential. And then you end up having...
It just like blows squeezes the
right. So it's, it's wind. High pressure at high pressure at the southern end of the Gulf of California, low. So high moving towards low will induce that surge of low-level moisture. And then other circulation patterns have to be in place to sort of steer it up here and move it into place. But we really haven't had all those sort of pieces come together until pretty recently, in the last week or so. To really have good, and again, it's like, what's a good monsoon day? It depends on who you are and where you're at. When we think about a good monsoon day, we want some kind of very intense, widespread activity that moves across the region. And those are big organized events. So you have to have a lot of things in place, which were all of those things you were talking about earlier, which is a lot of low-level moisture, steering flow, where you can move storms off of the mountains where they're going to form first because they have the most instability, and then be able to propagate into the lower desert areas where it's much harder to have that good thermodynamics. And so you have to have a lot of pieces to come together to be able to do those big events, to put down a lot of rain everywhere, which is why they only happen, really honestly, a couple times a year. Other than that, on the other end of the spectrum is if you've got a mountain sticking up into the sun and having that moisture, it's going to produce convection almost on a daily basis as long as that moisture is available.
So you can see these vastly different amounts during any one rain event. That's obviously related to topography.
You've got the topography inducing the convection, getting some of the outflows of that interacting across the city. We're putting up some more storms. And we got those sort of 10th to quarter inches around Tucson. It wasn't until the overnight hours where you actually had the big mesoscale convective complex, which is much more organized upper level, much better dynamics with upper level support that can cause large areas of thunderstorms to break out.
So wait, I'm gonna step back.
Okay.
What do you mean by upper level support?
I'm watching the different weather experts do discussions on the last couple of days, talking about things like inverted troughs, where you'll have cooling at the upper levels. So if you have cooler air at upper levels, you can move cooler air in over top of warm air at the surface. You're going to create much more unstable atmosphere. And if you can have areas of what we call divergence at upper levels, which will help exhaust out or actually cause ascending motions in the atmosphere, which will help support thunderstorm
uplift
development
and instability.
Mm-hmm. Yep.
So you have the cooler temperatures aloft, and you have divergence at aloft that helps bring the moist near surface air masses up, condense, rain out.
Yeah, it improves the thermodynamic profile. Yeah, and also there's sort of steering flow in the atmosphere too, which will help these storms to organize. What you want to have is broad areas of rising motion that sustains the convection. And then you can have these, you even watch them on radar. They're not a bunch of little small cells that are separated from each other. There's these big areas of widespread rainfall that will turn into these sort of broad areas of moderate rainfall afterwards. And then you can get events that last for multiple hours rather than that 30 minutes or 15 minutes of
And that's what happened here in Tucson.
Yeah, and it's what happens really frequently down in Mexico. And what we'll see is these large thunderstorm clusters sort of move from east to west across northern Mexico, and we'll end up seeing the outflows from them because there's all this rising air, and then there's all this precipitation occurring out of them, and then all this rain-cooled air then spreads out in every direction. Kind of like, if you've poured a bucket of water on the ground and watched that expanding wet area kind of move out in every direction. It's kind of the same thing in the atmosphere. And so on that front leading edge of that cool air, it's a mini cold front. And that mini cold front's going to shove air up. And if it does that in conditionally unstable air, it's going to cause convection to occur and fire off new storms. So it's the thing that you'll see across like Douglas and the border cities in Arizona, they'll see a lot of this, and they'll even get overnight thunderstorm activity from that. But we're a little bit too far north to see a lot of that activity throughout the season, often.
As these storms drop a bunch of precipitation very intensely, and they can generate pretty substantial winds.
Yeah, absolutely.
And that's part of the outflows. I mean, they can be upwards of 50, 60 miles an hour.
Absolutely. And so the drier the lower atmosphere, the more of evaporation will occur with these storms. And so it'll convert that precipitation into rain-cooled air, which then has energy to spread out in every direction and turn it into wind. A wetter atmosphere will end up typically having less wind and more rainfall associated with it. So it's kind of the wind is sort of early season. Phoenix will see more wind because lower elevation has usually less low-level moisture. So that's how those haboobs can sort of propagate to the north, and we'll end up having more rain. They'll end up having more wind. But when it's a really good, deep, soupy day and the low deserts are socked in, everybody can get rain all at once. So it's the beginning.
How do you feel?
I feel good. I'm looking forward. Let's just look forward, man.
Some of the things that we do know is that about a quarter of the days during the monsoon receive rain. So what's that, 25, 27 days, more or less?
For Tucson, yeah.
For Tucson. So, we've got quite a bit of monsoon action ahead.
I mean, we get so hung up on what happens right at the beginning of July. The busiest times of the monsoon is really late July and into August. And so we've got a lot to look forward to. It's early. There's still a lot to look at. We're going to be watching the East Pacific tropical storm season. There's been plenty of activity.
Those are really important later on in the season.
They are. The subtropical ridge is in a much better position to start to steer them. In the Gulf of Mexico.
At that time.
Yeah, and the Gulf of Mexico is lighting up now too. And Gulf of Mexico has been fairly slow in recent years. And every once in a while, in past years, a busy Gulf of Mexico season, those decaying storms can ride the easterlies underneath our subtropical ridge and actually produce weather for us too. We haven't seen that in the last 2 years, I think. So there's still a lot of exciting stuff to look at going forward.
What's your prediction?
Oh, man.
Come on.
Climatology.
That's our best predictor, climatology.
It's all I got. It's all I got right now.
Bet on climatology.
Yep, and there'll be error bars around it. That's for sure.
It's great to finally be back in the monsoon season. I love talking about this.
Me too. We'll both be sticking around.
It's when I pay more attention to the daily weather, and when I have my annual recurrence of watching YouTube videos about how to read a skew T-plot. Teaching myself some meteorology, and a shout out to we haven't done this. We should have had a shout out to Bob Maddox's weather blog that he writes for Tucson. It's really one of our go-to sources of information, and he updates it daily. It's called Mad Weather, madweather.blogspot.com. And for those of you who don't pay attention to it, it's definitely worth viewing on a daily basis.
Yeah, I think
just a shout out to him.
That's an indispensable resource. And Mike and Will, who write the WRF discussion too, so out of the Atmospheric Sciences department here at U of A, reading their discussion every day is what keeps me trying to get it's every year I feel like I know a little bit less about the monsoon because it just feels like there's yet another thing that I hadn't thought about that makes it more complex. It gets
more complicated.
It feels like it gets more complicated over time for sure. Wow. Which is fun. I think that's the cool thing about it.
Science is hard.
Science is hard.
All right. Well, thanks everybody for tuning in, and we'll come back in a month.
I think we'll be going for the halftime report.
Yeah, it'll be the halftime report.
It'll be fun to talk to you guys throughout the season.
All right. Well, thanks for tuning in.
The Southwest Climate Podcast is a production of CLIMAS, which is part of NOAA's Regional Integrated Science and Assessment Program and is housed at the University of Arizona Institute of the Environment. Mike Crimmins is a principal investigator with CLIMAS, a professor of soil, water, and environmental science in the College of Agriculture and Life Sciences, and climate extension specialist with the University of Arizona Cooperative Extension. Zack Guido is a research scientist with the Institute of the Environment and UA program manager of the International Research and Applications Program. The podcast is edited and produced by Ben McMahon, Research, Outreach, and Assessment Specialist with CLIMAS.
What do you read? Yeah.
I end up looking at weather maps late at night.
This is perfect. I mean, this should give everybody that's listening a big vote of confidence that we're not spreading fake weather news.